electron stands for electricity. And then statics at rest. So in electrostatics, we are dealing with point charges which are not moving. If I have a positive charge here, and a positive charge there, let's call this A and charge B. Charge A and charge B exert a force on each other. And here, because charge A is positive and charge B is positive, like charges will repel. So basically, we will have that as a force of repulsion between the two. But if I have charge D here, which is positive, and charge F there, which is negative, there will be a force of attraction. Unlike charges attract each other. Now, Coulomb found that there is a relationship between the force that the two charges experience, and he said force is directly proportional to the size of charge D and F, or charge 1 and charge 2. And he also found that force is directly proportional, is inversely proportional to the distance between the two charges. So basically, between D and F, there is distance there between the two, so distance squared. Now, the proportionality constant here will be F into a constant, Coulomb's constant, and charge 1 multiplied by charge 2 over R squared. Now let's have a look at what happens when charge 1 is increased by a factor of 2 and charge 2 by a factor of 3. That is, charge 1 becomes increased by a factor of 2, and charge 2 is increased by a factor of 3. What will be our new force? The new force will be F is equal to K 2 times charge 1, 3 times charge 2, all over R squared, and that gives us 6K charge 1, charge 2 over R squared. Now look out at what K charge 1 R squared is equal to. K charge 1 charge 2 over R squared. So this can be written as 6 and charge 1 charge 2 over R squared K. K is equal to F. So when charge 1 is increased by a factor of 2 and charge 2 is increased by a factor of 3, we'll have 6 times the force. Now let's see what happens when the distance between D and F increases by a factor of 3, we will have F is equals to Coulomb's constant, charge 1, charge 2, and you said the distance is increased by a factor of 3. So this becomes K, charge 1, charge 2, over 9R squared. This can be written as 1 over 9 into K, charge 1, charge 2, over R squared. But we know that K, charge 1, charge 2 is the same as the F. So this will be 1 over 9 multiplied by our F, because so basically if the distance is increased by a factor of 3, the F will decrease by a factor of 9. That's what you have, because this is R squared. Okay. Now, the Coulomb's constant is 9 times 10 to the power 9 Newton meter squared per Coulomb squared. That's what we have. Now, let's have a look. Let's use let's use Coulomb's law to calculate for the force between particles. Let's take the first question here. Let's take the first question here. The first question here says that says two equal charges of 1 coulomb are separated in the air by a distance of 1 meter. What is the magnitude of the force between them? One kilometer, it says two equal charges. So charge 1 is equal to charge 2, and that is equal to 1 coulomb. And then distance between them is 1 kilometer. And then they say the force between the charges is unknown. By Coulomb's law, F is equal to K, charge 1, charge 2, over R squared. That will be equal to 9 Newton meter squared per coulomb squared multiplied by 1 coulomb, another 1 coulomb, and then this is R squared, is 1,000 meters. That is a square. That will be 9 Newton. Coulomb multiplied by coulomb squared is going to cancel with that. 1 multiplied by 1 is 1. And we have 1 Newton, 9 meter squared, Newton, divide by 10 to the power 6 meters squared. I would appreciate that that will go down. And this can be given as 9, 10 to the power 9. The laws of exponents goes up, Newton, and that will equal to 9, 10 to the power 3 Newton. So 9,000 Newton between the two charges. Now, we need to establish, because force is a vector quantity, we need to establish direction there. We need to establish direction. They said basically we will expect this to be the same, therefore it will be repulsion. That will be repulsion. Now, let's have a look at the second instance, or the other instance, where you have charge 1 here and charge 2 there, and the distance of separation R here, let's say 6 centimeters. Now, the charge on 1 here, 44 times 10 to the power minus 6 coulomb, and the charge here is negative 9 minus 6 coulomb. Now, they say charge 1 and charge 2 are brought into contact. Let's charge 1 and charge 2. They touch each other. This is the first scenario. They touch each other. The third part is that the two charges are brought back to their original distance of separation, which is 6 meters, 6 centimeters. There is charge 2 there. There is charge 1 there. Now, question one, we have to find force in the first scenario. And then the question 2, we find force in the third scenario. Now let's see. For question 1, we know that Coulomb's law says F, K, charge 1, charge 2 over r squared. That is 9 times 10 to the power 9 Newton meter squared per coulomb squared times 4 exponent minus 6 and negative 9 exponent minus 6 coulomb. And then this 6 times 10 to the power minus 2 meter squared. 9 times 9 is 81. 81 times 4. That will give us 4. 8 times 4 is 32. Times 10. Negative 6 and negative 6 is negative 12. And negative 9. That will give us negative 3. Coulomb here. Coulomb multiplied by coulomb here will be coulomb squared. Multiplied by coulomb negative 2 cancels out. We remain with Newton meter squared divided by 36 times 10 to the power minus 4 meter squared. Appreciate that meter squared will cancel out there. Now 10 to the power negative 3 divided by 10 to the power of negative 4. This will give us 324 divided by 36 times 10 to the power minus 1 Newton. So 324 divided by 36. That gives you 9. 9 times 10 to the power minus 1 Newton, which is 0.9 Newton. And it's attractive force, because these are unlike charges. Now, in scenario 2, they are brought into contact. Now, what's going to happen? It's going to be 4 plus minus 9. The answer is going to be negative 5. This is the positive 4 here, plus the negative 9 there gives you negative. So, when you separate the two charges back to the original position, by just separating them, they have to share this negative 5. So this will be negative 2.5 microcoulomb. This one will be again negative 2.5 microcoulomb. Now, for question 2, we can go to the next page. For question 2, F is equal to K, charge 1, charge 2, over R squared. This is 9 Newton meter squared coulomb multiplied by negative 2.5 Now this is identical, charge 1 and charge 2. I just square that, and that was squared. That will be 9 Newton meter squared. Coulomb here. Per Coulomb squared. 25 times 25 is 625. 10 to the power minus 12 Coulomb squared. And this is 36 times 10 to the power minus 4 meters squared. Now, Coulomb squared will cancel with that. Meter squared will cancel with that. Now, on the top, I have 9 multiplied by 6.25, 10 to the power minus 3. On the bottom, I have 36 times 10 to the power minus 4. So, basically, this is 9 times 6.25 divided by 36. That gives you 1.56 times 10 to the power negative 1. This is 0.156 Newton. That is the force between the two charges after they touched each other. This should be enough. We'll meet in electrostatics tutorial or electrostatics lecture 2.